I'm Rebecca Kreipke. I'm the manager of the Western Markets Field Application Scientist team at Molecular Devices, supporting our biopharma high-throughput clone screening portfolio. So the QPix SE is the next evolution of our QPix 400 series of high-throughput microbial colony pickers. So what's really great about that is it's able to decrease the footprint compared to some of our past models in order to be able to give our researchers more flexibility in where they can put these into their workflow, as well as being able to hit some customers who are earlier in their research journey and give them a really great entryway into that automation by providing a smaller footprint but still high throughput instrument. The current plasmid prep process that most people engage in comprises a lot of very laborious manual steps. And so what we do with our plasmid prep starter bundle is we're able to offload a lot of those laborious repetitive processes onto instrumentation and frees up your scientists to be able to engage in more intellectual pursuits rather than being stuck at the lab bench doing manual things like colony picking or plating. So we find that people are experiencing time and cost savings in two main areas with our plasmid prep bundles. So the first is obviously going to be your walkaway time. So when you're able to introduce laboratory robotics into a manual workflow, you're able to free up, again, your scientists so that they're able to engage in other tasks in the lab and not necessarily the repetitive, laborious ones. The second place that we see a lot of time and cost savings happening is in the reduction of user error. So when you use laboratory robotics, you're shifting that onto a more dependable high precision robot like our QPix, and that makes sure that you're not going to miss any samples or double pick colonies, and so you're sure that your products are both more pure as well as that your documentation provided by our software solutions are going to be more robust, and so you're also saving in the decrease in user error that you see when you shift to robotics. So while we're working with Molecular Devices, we really make sure to tailor all of your robotic solutions specifically to your workflow. So during that process, we will really understand your workflow, what kits you're working with, what reagents you're using, and be able to make sure that whatever we're designing for you really meets that needs. In addition, we strategically partner with a number of people who have solutions that are tailored specifically to most of the widely commercially available kits, as well as have been able to develop several solutions for people who are doing more bespoke or in-house processes. So the QPix uses a number of morphological characteristics in order to determine which colonies meet your picking criteria. So we have a number of different shape and size parameters that are measured by the imaging associated with the QPix. We also have the ability to do colorimetric or fluorescence-based picking. So if you have a fluorophore that you want to detect or do blue-white screening, we're able to do that with the imaging based on the QPix as well. And what's really nice about that is rather than relying on subjective assessment by an individual researcher when choosing what colonies to pick, you're able to use the objective data that is generated by that imaging on the QPix in order to select which colonies are going to give you your best hits. You can do all of your plating and streaking on some of our QPix platforms, and what's really great about this is it allows you to, again, offload that from your scientists onto a robotic solution, so you're able to, one, track your samples much more robustly because you're doing that all through the software, as well as making sure that you're much more consistent in your volumes of your transformants that are being plated, as well as the patterns of your streaking, because that's all being handled by our high precision robotics. And so this just makes sure that, again, you're decreasing your user error, which is going to, in the long term, give you a lot of time and cost savings because you won't necessarily have to repeat your experiments in order to make sure that you're optimizing on a transformant by transformant basis.